Hi everyone, my name is Roman Zatitsky and I'm a product manager at EngX. I'm also the host of today's webinar. Today we'll be joined by two speakers, Saurabh and Pratik, and we'll be talking about all things about data structures and algorithms for the interview for the position with 4+ years of experience. And I believe it's going to be a really incredible session to get some hands-on insights on what a real-life interview looks like. This video is brought to you with the support of EngX. EngX is a program developed by EPAM aimed at enhancing and propagating best software engineering practices and processes across the organization and all the teams level. It offers a suite of services, tools, and educational programs to continuously improve software development performance, smoothly integrate Gen AI tools into everyday work, and foster a culture of excellence, and also a culture of innovation among engineering teams. If you enjoyed this video, be sure to check out the links in the description and explore more about what EngX has to offer on engineering excellence for your teams. So now I'd like to give a couple of words to introduce yourself. First, for the interviewer, Saurabh. The stage is yours.
Hi, hello everyone. My name is Saurabh. I'm a lead engineer at EPAM system. I have kind of 14 years of experience in IT industry. So throughout my journey, I was kind of involved in the product development and also kind of work on the Java DSA system design aspect of and so today I'll be playing the role of the interviewer, where I'll be conducting the interview on the Java DSA.
Wow, thanks. Such a cool experience. You're such a cool guy. And thank you for joining us today. Now, our candidate, Pratik. The word is for you.
Yeah, hi everyone. So I'm Pratik Jagtap and I'm from the EPAM system and I'm playing the role of the candidate. And regarding my background, I have the near about 7 years of experience that is in the backend development, like the application with the Java, then with the DSA and the system design.
Yeah, thank you for the introduction. And it seems that we are now all set up. So let's jump into the interview process. There we go.
So the format of this interview will be I'll be asking some thoughtful questions, and then we'll go into the problem solving, talk about. So the idea is to you kind of tell me about the requirement, the scope, and what kind of data structure you'll be using, and then going into that the edge cases, and then kind of implementing it. Okay. So can you please tell me what is the difference between linked list and array list?
Okay, so LinkedList is basically working on the address location and the node part. Okay, so it is storing the two things: actual data and address of the that data, address of the next data, and the array list is storing into the array, that is the actual array internally. So if we talk about the linked list in Java, it is using the W linked list internally. Okay, and basically it is pointing the next location of the data as well as the previous location of the data in the W linked list.
And how does that memory allocation will happen with respect to static versus dynamic? So how it is different in ArrayList and how it is kind of different in list?
So in ArrayList, it is storing the data in the continuous memory location. Okay. So if the one element is stored at the one location, at exact next location, it will store the second element. But in the linked list, it is storing at the different memory location. Okay. But when it is pointing to the next element, it is storing the address of the next memory location into the first node of that particular linked list. So the location is the continuous in the array list, but location in the linked list, that is not a continuous. So that's why the linked list is becoming the dynamic.
Okay, so let's say if I have a kind of constraint in the space, so if I have to choose between linked list and array list, what kind of data structure I'll go with?
I will suggest that is if there is a constraints in the memory location, then we should go with the linked list, because according to the structure of the linked list, it is storing the data at the random spaces. So we can use the whichever the available space in our memory, we can use it in the efficient manner by spreading the data and storing it the memory location into the current node. So that's why we should choose the linked list over there.
Okay. Okay. So can you please tell me how's the internals of HashMap looks like?
Okay. So internally, the hash map is storing the for our usage, it is storing the key and value. Okay. But internally, it is resolving the collision. So that's why it is storing the so before Java 8, it is storing in the linked list. That is a doubly linked list. Okay. But in the Java, it is storing in the that is binary search tree. So where the each and every value will be stored into the binary tree, so that that is a key will be stored in the binary tree, so that whenever we get the one particular element in the hash map, it is searching by using the binary search algorithm. So it is giving us the more efficient as compared to the linked list.
So let's say like if there's a collision happens, the key, right? How it kind of resolve that? What kind of techniques it uses?
So there are the multiple technique that we can use for resolving the collision. That is the probe cubing is the one of the technique that is currently using in the hash map. So what it is doing, it is internally calling the hash method, okay, which is creating the hash code. And according to the hash code, it is storing the data, so that whenever the collision is happening, it is creating, it is calling the hash method, that is the hash method. And this hash method is creating the hash code, and so that our data will be stored at the different location of that hash code. So that is the linear probing, and the that is probe cubing is the different method which we can or the use for the that is collision, if the collision is happened.
So you mentioned about the linked list, it is being stored. But how does it guarantee that like if we have a last set of data, how does it kind of, so let's say like if you have kind of a key with have like so it has like multiple collision happen, right? Now you are storing that value. So now how do you kind of so let's say like if you have a lesser space, right? Your memory size is very less. Now I'm like, how do you kind of like it kind of resolve in a faster way to provide you the access of the values for that particular key? So let's say like if you have a key XYZ, and then like you have a corresponding is a kind of values. So I mean like the same key can have multiple values, right? So now if I have to access based on the key, how can I fetch those?
In case of the that is linked list manner, okay. So whenever we have the same key, okay, and we let's say the hash code is also calculated in the hash method, it is the same, okay. Then it is storing in the linked list in the linear manner. So first of all, it will fetch the full list, that is the full linked list of that particular key, and then it will traverse the one by one, okay. And once it is reached to that particular element which we want to fetch, then it will return the value of that particular element.
But in that case, the complexity will be like O of n, right? But if I have to, let's say, like optimize it, how can I do that?
Okay, so that's why when before Java 8, it is using the that is linked list for storing the value of it. Okay, but in the Java 8, it is improved. That is whenever we have the large list. Okay, it is converting to the binary search tree, and whenever the node we want to search, it is search within that list in the binary search that is algorithm. Okay, and when it is started searching, it is giving us the less time complexity. So if we in the linked list, it is giving the time complexity that is O of n, but in the binary search, it is giving the log n. So that's why in the Java it is converted to the binary search.
And how does that merge sort and quick sort are different? How like which one is better if I have to consider?
Better we cannot say, but at the different scenario, we can use the different algorithm. Okay. So let me give the scenario for the quick sort. Let's say we have the very large number of the data set, okay. What the quick sort is doing, it is dividing and then conquering the data, okay. So it is dividing on the basis of the one pilot element, and this pilot element is deciding on we have the data. It can be a middle or it can be a lesser. Okay. According to this pilot element, it is dividing on the basis of the smaller element of the pilot element and the larger element of the pilot element, and then it is dividing. It is dividing till the end of the list, and then again conquering by sorting it and conquer it, and then merge the data into the single list by giving us the sorted array. Okay. So why this quicksort is not suitable for the small data set? Because we are dividing and then conquering the array. Okay. So this will become the heavy operation if we use for the small data set. Okay. Because for the each and every element, we are dividing and then conquering the data. But in the merge sort, we cannot say like that. That is, we are that is good for the large data set, but the small data set merge sort will be the used because it is merging at the that is each and every element. It is calculating if it is a lesser, it is putting the data. If it is greater, it is rejecting, and it is putting the data from the different data set. So merge sort is creating the subset, and quicksort is not creating a subset. Quicksort is creating the data set on the basis of the pilot element.
So if we consider the complexity, what is the complexity in the worst case scenario in both cases?
For that is quicksort, it is giving the n log n. Okay. And the same for the merge sort also, but I'm not sure about the merge sort.
Can you please share screen? I'll give you some kind of problem solving question. Okay, so I have shared the problem statement where I want you to kind of design and implement the leaderboard, and where three methods I want you to kind of implement it. One is like increase the score by one by one, where you'll be given the player ID. What you have to do is like in that increase method, you have to whatever the current score you have, you'll be kind of incrementing by one. Okay, let's say like player won the game, it will call that increase the score by one method, and the current score of that player will be increased by one. Okay. Similarly, for the decrease the score by one, the whatever the current score is there, it will be decreased by one. Okay. And the get leader is something which is we want like the player ID with the max score, right? So at any point of time, these three methods will be called. So as a service provider, you have to kind of come up with this implementation. What I'm looking is like from as part of this assessment, I am looking is like you will be coming up with what kind of data structure you'll be using, what will be the complexity of these three methods, and then also identifying the edge cases for these three methods, which you'll be implementing, and your code should be functional. Okay.
So let me clear my understanding. Okay. So I need to design the leaderboard where we will calculate the score of the each and every player. Okay.
Basically, the score is something which you'll be you have to store it at your end, because that's how like you kind of performing this increase and decrease method, and based on those score, you'll be kind of giving the get leader information. The data side, like you only have the player ID, which is coming as part of your increase and decrease method. Nothing else will be coming.
So this increase method will be increase the score by one. Okay, I have that is some corner scenario where we should consider. Okay, that is the player ID will be the string or the integer. Which one I should choose?
I mean, like you can consider both. I mean, like it's fine if you can consider integer also, or you can consider string also. I'll leave that design up to you.
Okay. Okay, I will decide this later. Okay. Okay. And if let's say the decrease score by one is directly called, that is before any increase. Okay. So shall we decrease the score to the negative number, or we should keep it as
No,
a?
want to keep the score as positive only, so we'll kind of restrict that.
Okay. 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 Then that is Okay. I can use the any data structure or the my own that is design class to store this data, right?
Yeah. I want to see your kind of how you'll design it, and then talk about the complexity. Then we'll decide whether to go ahead with that approach or not.
Okay. And which one we are giving the priority? That is the space complexity or the time complexity. So I will think about the according to that the solution should be look like.
So the focus should be on the time complexity first. We'll see if we can optimize the space as well.
Okay. Okay. And in case, let's say we didn't store any data and get leader is getting called, then what should be our response?
Yeah. So in that case, I leave the design up to you, but ideally you should throw exception.
Okay. Okay. Okay.
And even for the decrease, you should throw exception when there's a score is negative.
Okay. Okay. So right now, as per my thinking, this will be the scenario that I will handle. I will ask you in between if I thought any if any thought coming to my mind.
Sure. Yeah.
Yeah. So to solve this problem, what I can do. So initially, what I will do, I will store the data that is the player ID and the score I need to store. Okay.
Mhm.
Okay. So I will store the data to the hash map because we have the key and value. Okay. So in the hash map, what the key will be the player ID and the score will be the that is value. Okay. So what we will do in the increase score by one, what we will do, we will fetch this player ID. If the score is present, okay, we will increase it by one. Okay. So it will give us the time complexity that is the O of 1 or increase the score by 1. Now coming to the that is decrease the score by 1, the same thing we will fetch the player ID. Okay. If the player ID is present, then we will check the value that is the if it is a greater than 0, then we will decrease it. If it is not a greater than 0 or that is the it is a 0 only, then what we will do, we will just put it as it is, that is a 0. Okay, because we don't want score in that is in the negative scenario. Okay. If it is the something that is we will check that if the that is decrease score is getting called and the already the value is 0, then we can throw the exception at that particular condition also. Okay.
Okay.
So again, the it will give us the time complexity that is the O of 1. Okay. Now coming to the get leader, what we will do, we will sort the map on the basis of the that is value, whatever the present in the hash map. Okay. After sorting, whichever is the first element, that is by the decreasing order, whichever is the first element, or the first entry in the hash map, that will be the leader we will consider. Okay. It may be possible there will be the multiple leader at the same place, right? Or shall we keep at the same only?
So I want that the only one player ID it should be returned. Um, I'll leave. So for now, I'll any one of them should be fine. But let's say if we can have different variations also, like most recent one uh, or the least recent one, right? Those variations also your design should be flexible enough to kind of accommodate.
So to sorting the hash map, the this leader will give us the that get leader will give us the time complexity that is the O of n.
So
Otherwise,
when
we can
sorry, when you sort it, it won't be off and right. It
no,
will
sorry,
be
sorry. That is the n log n if we sort it.
yeah. So n login is very high complexity. What we are looking is much lesser than that. So how can you optimize this?
Okay. So That is the
I mean,
increased
like
score.
even like if I'm like if you traverse the map also, I'm like the complexity will be O of n only, right? You don't have to kind of sort it, right? That also will be O of n, but O of n is very high complexity. Let's say like if you have a millions of players, uh, then O of n is kind of very high complexity. So how can you optimize it?
Okay, so you mean to say, let's say the hash map, we create one variable that is the max, and we traverse the value, whichever is the max value, that will again give the O of n.
Correct.
Okay, okay. So in that case, so you mean to say that is we need a time complexity that is less than O of n, right?
Correct. I mean, like think as like a kind of a platform service where you'll be providing these three method, exposing these three methods, right? What we are looking is like the optimized one, so that like the performance wise, like I'm like for your service, like the performance will be like better, right? So think like it should be like less than O of n when it comes to the time complexity.
So to find the better solution for these, we can use the multiple data structure at the same time, right?
Yes, yes, yes. So right now, though, I gave that flexibility to use. I mean, like you have a space flexibility. Just focus on the time complexity.
Yeah, sure, sure. If we use the tree map, that is the key will be the score, and
Mhm.
the value will be the player ID. And tree map is already sorting it. We just need to provide the that is comparator. But again, I could see the tree map.
How
If
does
we
that comparator works in the tree map?
Yeah, we can create the that is comparator within the like, let's say the, if we use the new tree map score and player ID. Okay, but again, these I could see these will give us the time complexity that is e of n log n. It is not giving us the log n that is less than n.
Right, because it is working on the entry set, right? When you go
Yeah,
with the value.
correct, correct, correct. So we can do like this. If we use the comparator over here, okay, B A.
But
So
in this case, the B and A is a score only, right?
correct, correct.
Because it does not have the player ID information. Because the tree map sorting, the natural sorting works on the key, not on the values, right?
Pass the key over here, the score, but it is calling this comparator method every time. So it is giving us the n login for the sorting the tree map. Okay. Let me just think the solution.
Okay, so how will you store that element? I mean, like, how will you store the element in the tree map as part of like you'll be doing it as part of increase and decrease, right?
No, no, no. For storing, it is using the hash map only. Okay. But whenever the get leader is getting called, it is storing, it is fetching the all value of the hash map and storing into the tree map. Okay. And this, whenever it is storing to the tree map, this particular compare method will getting called, and this will sort in the tree map only. But the actual data set will be stored in the hash map only for
Right.
the
Right.
full.
So when you do that insertion and the sorting, the automatic sorting based on the comparator will happen. It will take like off and login, right? I'm like,
Yeah, N
yeah,
of N login. Yeah, correct, correct, correct.
yeah. So then like there'll be a kind of better way, kind of you can optimize the sorting, right?
So what we will do, Saurabh? So we will create a tree map, okay, and we will store the score on the as a key, okay, and we will store the hash set of the player ID, okay. So this will be the set of the player ID, whichever have the same score, okay. Let's say we have the player that is A, B, B, A, B, C, D. Okay. Let's say the B and D having a same score, 5, and this will have the 7, and this will have the 10. Okay. So let's say the 5 and that is B and D have the same score. This B and D will save into the will be stored into the same hash set. Okay. So whenever this tree map will sort the things. Okay, whenever we will try to fetch it, okay, we will fetch the last element. Okay, as the score as an integer, it will sort automatically in the tree map, and whenever we'll try to fetch it, it will fetch the we will fetch the only the last element that is in the increasing order of the tree map.
Yeah. So basically, like you'll be going ahead with the default sorting, which is on ascending order, and you'll get the last tree. Okay. So hash collection you are using because you have a same score can have like multiple players. That's why like you're using collection. But why hash check? Why not go with a different data set?
Because this player ID is the unique one, right? This player will not be a duplicate one. That's why.
And also like you need to kind of have like you need to perform that insertion or deletion on those same score,
Yeah,
right?
that
Perform,
that I will the hash map for this.
right.
Whenever the we will store the insertion and deletion actual data set will be the hash map. Okay, we will fetch the value from there, and whenever the increasing and the decreasing will happen, then we will update the both data set, that is hash map as well as the tree map. Okay, so let's say in the increase score, let's say the increase score for these three, okay, that is a player a, this method is getting called, that is increase score by 1, then it will increase to the 4, right? So in the tree map, the entry for this a to the 3 need to be deleted, right? So we need to perform the deletion operation into the increase score as well as the decrease score. Okay, so that deletion operation will be happen by using the login, that is the O of login time complexity.
Okay. So when you are inserting a new score or deleting a new score, then like or deleting the old score, that time there'll be kind of internally it will kind of restructure. So that
Right.
takes like log n. Okay. So n is here the score, right? Or what is n here?
That is a player, whichever the stored in the hash set.
But your tree map is on the score, right? Your keys are a score, right?
Yeah, n will be the score. Yeah, correct. You are correct, Saurabh. Yeah, n will be the score. So tree map is storing the score as an a key, and we need to traverse this key. Yeah, that's why that is the n will be the score. Yes.
So what is the overall complexity when it comes to increase, decrease, and the get leader?
So for get leader, it is the O of 1 only. Okay. For increase score by 1 and decrease score by 1, that will be the login. So overall time complexity will be the O of login.
Sure. So go ahead with the implementation. You can define your edge cases through your different scenarios through main method, and then like what is expected, the outcome of your methods, right? You can kind of list that, and then like you can execute it as part of your.
Yeah, sure. So I will create the that is object oriented structure over here. So I will create the separate class for the handling all this scenario, and I will pass the data from the that is the main class with the main method. Okay.
Got it. Okay.
Shall I go ahead?
Yeah. Go ahead.
I'm considering these as a string. Okay. Clear ID. So one question, Saurabh. So get leader will return only string, right? That is the whichever is the
Right. The player
okay.
ID.
Okay, will return their ID.
Player ID the max score.
Okay, player ID with max score.
So you fetch the current score, then
Yeah,
like you the map with the score.
yeah.
Okay.
Now I need to update the tree map also. Okay.
Mhm.
So what I need to do, I need to fetch the map that is sorted map dot get the current score. I need to fetch it. Okay. Um, then I need to update the tree map. Okay. Get current score. Their ID. Okay. If this is the sorted map, dot get current score dot contains the player ID. I need to remove that. Okay.
Okay. So existing score, you are kind of removing the current player. Okay.
Correct. Correct. Yeah. Yeah. score data map dot get, sorted data map dot get, current score things. So this condition is also not required, I guess. I can directly remove that. Remove the player ID. Okay. I will remove from the sorted data map. Okay. And what I will do, I will update with the new score. Put it absent. With the new score. And then I will update. This is the empty hash set it is initializing. So I need to get the new score and add to the player ID. Okay. So same thing I will do it for the decrease. Current score I will create. Okay, I will. If it is already 0, then if then I need to throw the exception, right?
Yeah.
Okay. If it is not, then I will leaderboard.put with the new score. So that HashMap.get current score.remove it from the tree map, put if absent. Okay. Dot add here ID. Okay. Same thing has happened with these. Okay. Now I need to fetch the this is the sorted data map. Last entry I need to get it. Last entry is returning this dot get value. Get value. And if his is empty, sorted data map is empty, then we need to throw the exception, right? So what I will do, I will create the leaderboard. Okay. Here one.
So let's say like if I call that uh, get leader at the top.
Yeah, so it should throw the error in that case. So I have added, let's say the sorted data map is empty, then it should throw the error.
Sure. We can we validate that?
Yeah, yeah. Yeah. So shall I comment this thing?
Yeah.
Let get leader. Okay, so what I'm doing, I'm storing the okay. Shall I run the code?
Yep. Go ahead.
Yeah, it is throwing the leaderboard don't have the data.
Okay. Now just is this get leader after line number 14?
Okay. So we need to remove from here.
Yeah. Hmm. There's an exception, right?
Yeah, yeah, yeah. So we need to check here that is the player ID is exist or not. Okay. So before removing that, we need a that is we need to check if this particular score have the data or not.
Okay.
Right. Okay. Contains the player ID. Then we need to remove that.
I think the same thing you have to do it on the decrease also.
We need to check first of all empty, and then we need to check
It will be a contains key, right? Or string. You can also put it into a
No, this contains method is the uh, is for the hash set.
okay. No, what I'm saying, like you can kind of club it into a single if statement, right? Instead of having nested. That will be and condition, right?
Yeah. That is correct. Yeah. We can add that. But if it is empty, okay. For example, let's we have added the with the and. Okay. If it is
Mhm.
empty, it will also check this particular condition. Okay, and then it will throw for this particular get method.
No, so
For
first, so how does the evaluation happen? It will be first, or it will check for empty, right? If it is false, it does not kind of evaluate for another condition, right?
right. Or else we can directly call the method of the remove over here. Instead of checking the contains, the remove will not remove the element. It will not throw the exception if the particular element is not present. So let's check that. Okay, it may be possible it will throw the exception if we remove these things. So what we are doing, we are calling decrease also, right? So we need to put the same condition in the decrease also.
Can we also do this thing? I think you have a condition, right? Sorted map, put if absent for new score. Can we also do it for new?
Yeah, sorry.
Okay, so you want to check for contents key, then only go ahead. Okay, got
Then
it.
only will go ahead, correct. And the if condition I will store the content map dot get dot.
This should be fine, right? I think contains key will be fine, right? You don't have to go ahead with other, right?
I think so. Let me just check. Okay, player one.
Right. Uh, okay.
Okay, let me try to decrease. This is the increase. Yeah. This is the player one only because decrease. We are decreasing the player two.
Yeah. So let's say like you can increase player two a couple of more times.
Okay.
So call player two. Do you get the player two after this one more? Yeah.
Okay.
I'll try that.
You get the player two right now. Okay. Okay.
Okay. Right. What will happen if the score is same.
Okay, let me just test. It will give the one of them. Okay, but we can test that thing. So
Yeah. So
let's say
you have a player ID 1, which is having a score 1, 2, 3.
the one that is this is the increase. This is
Mhm.
the decrease. Okay, so this is 3. I need to put the one more player ID 1.
Right.
Okay. Now this is the same number, that is player 1 and player 2. Okay.
Correct.
So let me just try this thing. It will give the one of them. Okay. It is giving me a both. Okay.
Both.
Let
Right.
me, yeah, let me, I have over here, I'm returning the, that is both value, right?
Yeah.
It should give me a one of them right now.
Right.
Yeah. It is giving me one of them.
Good. Okay. So let's say like so this is your kind of like happy pass scenario. Let's say like if we have to kind of take it to the production, there will be some kind of what kind of challenges do you see with your respect to your code?
So for example, that is main challenges. Let's say we are designing the actual leaderboard. Okay. Then we should think about the large data set. Okay. As well as with the large number of requests from the many of the customers or the many of the users. Okay. So main challenges over here, we are using the in-memory data structure. Okay. If we are designing the application, then we should not. We should use the something cloud cache over here instead of storing into the in-memory data structure. Because we are storing everything in the tree map and the hash map. Okay. Instead of doing this like this, we can store into the cache. Will give us the memory utilization efficiently for the large data set. Okay. Another thing over here that is we are doing, if let's say we have the large number of requests coming to the this particular method. Okay, it may be possible it will give us the time lapse because of the this is not a concurrent execution of this full implementation. Okay, we can implement by using the concurrency to give us the that is efficient or the give us the less.
So what kind of challenges do you see with respect to concurrency? What are the challenges coming as part of your concurrency?
uh, for um, for this data set we can use the concurrent that is concurrency collection framework.
So what I meant is like what kind of challenges with respect to, so let's say like if two thread is accessing increase or decrease method.
So in that case, let's say the two or the many thread is accessing the same method, then it will give us the that is concurrent execution or this we can the data will be the flickering in between the multiple thread. It will not give us the that is synchronized data. Okay, it may be
Okay.
possible because we are not using over here the concurrent that is collections.
See, what about consistency? Do you see consistency issue be also?
Yeah. Correct. The consistency we can also face the for the if we get the large number of requests and if we use the multi-threading over here.
Mhm. So what kind of consistency issue do you see?
Okay. So updating the leaderboard map as well as updating the sorted data map in case of the increase score and the decrease score method. Okay.
Mhm.
Uh, and if the one thread is increasing the score and another thread is decreasing the score, and in between the get leader is getting called, then we can get the leader that is false leader, or the we can say the wrong data it will return, wrong leader it will return. if the
Got
multiple
it.
thread is facing the increased score and decreased score.
So how do you resolve this concurrency issue? Like what are the ways like you can kind of mitigate that?
We can use the concurrent that is collection framework for the map as well as tree map. Okay, and for hash set, I'm not sure we have the concurrent data set. Okay, uh, and for whenever we are updating the or we are this particular method is getting called both or the that is get leader also, then we should maintain the synchronization by using the any log or the synchronization mechanism. Okay, so yeah, that thing can handle the that thing can handle the that is consistency issue.
But let's say like if you're using synchronization, right? I'm like it is not kind of helping. I'm like there will be some kind of performance bottleneck, right? Because multiple threads. I'm like one thread has to wait for other thread to be completed, right? I'm like here the score is something which is kind of changing, right? Where you are kind of updating the current like your new score for the player ID, right? So I'm like, what can you do to kind of resolve this? I'm like, still like you can kind of not compromise on the performance.
So collection framework is the that is a concurrent collection framework is the one solution for these. Okay.
Right, but yeah, the write part is kind of synchronized. The read part is still kind of issue, right?
Yeah. So we can do one thing. Okay, we can apply the synchronize to the particular block of the code only, which is affecting to the current data set. Okay, for example, let's say we have the one player ID and we are
Like if I have a player ID one, I have
okay.
to wait for that particular block to be executed uh, for the player ID to kind of move forward, right? I'm like here my kind of score is something which is kind of keep changing, right? I'm like it's kind of getting changed, right? What can I do to kind of make it score as my thread safe instead of like putting that the block entire block to be
So you mean to say that is only the score? Then we can use the atomic integer over here. Okay.
yeah. So atomic integer will help you to kind of make it thread safe for the score, right? So
Yes. Yes.
any point of time when you are kind of updating the score, it will fetch the latest one, and then like you'll be updating that the current one.
Very good. Yeah.
So I'll have another problem which I want to give you. I'm good with this problem statement. So let's say, like if I have to kind of uh, I have an integer array. Okay.
Okay. So you are
Uh,
sharing some.
yeah, I'm sharing it with you. And what I wanted it is like I wanted you to kind of give me the sub array with the largest sum. Basically, like you're returning the sum value, but it has to. So the sub array has to be contiguous, right? So in this case, right, if I consider the sub array is like 4 minus 1 to 1, right? Uh, I'll
Okay.
get the largest sum as 6. So which will be 6 will be my output.
Okay. 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 Let me. That is what I need to do. That is largest sum sub array.
Yeah. So for the contiguous sub array, basically.
Okay. Continuous sub array.
You
Okay.
have to take that element which is in contiguous manner.
Oh. Okay. Okay. So I need to give the largest sum of the sub array. Okay. So what we will do, um, this can be solved by using the Kadane's algorithm. Okay.
Mhm. So what is cadence algorithm?
Okay. So what it is doing, it is calculating the max of the array. Okay. And whenever it is going to the negative number, okay, it is replacing to the 0. Okay. So it is storing the one. It is creating the one variable which is storing the which is initializing as a 0. That will be a max, and again we will calculate the current max. What it is doing, it is checking the max and the current max, whichever is the greater, that will be the max. But whenever the current max or the max is getting to the negative number, it is coming to the 0 again. Okay, so it is not maintaining the negative value. Okay, so it is maintaining the positive value only.
Got it. So what is the advantage of using Kadane's algorithm here?
For calculating the if we use the that is brute force, we need to that is calculate the addition of the combination of the each and every element, and then we will decide the that is whichever is the max of the sum. Then we will decide that that will be a max, and we will return the that particular max value. Okay, but if you use the cadence algorithm over here, the calculation of the sum of the sub array, it is giving us in the that is time complexity of O of n.
Okay. So basically, it is kind of improving the time complexity, right? Otherwise, you have to kind of take the two pointers or the two loop in order to find the
Yeah, yeah.
last. Okay.
Basically, cadence algorithm is working on the sub array. Okay, instead of the sum, we can pick up the any operation also. Okay, so this is the well known solution, or the we can say reusable solution for the multiple problem.
I mean, like you were kind of knowing the previous whatever the sum like previously, checking the current sum, like whether it is kind of increasing or decreasing, and accordingly you are kind of updating that the value. Yeah,
So shall I start implementing?
sure. Go ahead.
Let me just run this thing. Okay.
What is current max here?
Current max, it is calculating that is the sum of
Okay.
the current value. Okay, so let's say it is coming to the first position. Okay, it is calculating the 0 plus minus 2. Okay,
Mhm.
let's say it is coming to the 1, it is calculating 0 plus 1, like that.
Got it. Okay.
Is it the correct output for this?
No, it will be 6, right? So you have a 4 minus 1, 2, 1, right? That will be like 6.
Okay, this one, right?
So you need to you need to update your kind of current max with the sum, right? I think it's not a current max, right? You have to current sum. You have to see
Yeah,
like
yeah, yeah. Right. That is current sum. We can over here, and this current max I need to update with the sum.
correct.
Hmm. Current max is greater than yeah. That will correct. It should run now.
I think you don't require a statement like 7, 8, right? Because what you're doing is like you are changing your current max and checking whether the current max is greater than uh your current sum is kind of greater than the max sum. And if it is there, your max sum will be updated. If it is negative, you'll be uh, kind of changing to 0, right?
So you meant to say this is not required. This should be above. Yeah, this is not required then. Hmm.
Right. But this case will not work for one edge case. Oh, what can
Okay.
be a case here?
For the negative scenario, if the let's say the all number are the negative, okay,
Yeah.
then
Mm.
it will not work.
Right. So what can you do to kind of change that? Right now, your current max is 0, right?
Yeah, right. Understood. We can do over here. That is, we will maintain the current max again. The that is mean value of the integer. Okay, and in that case, we will remove this situation. That is
Or
condition.
or you can put that the first element of your array itself.
Yeah, that is also fine.
Uh, okay. Uh, just check the -2, -1, -3, -4.
-4. Okay,
I just remove other element.
so we can make it as a
Yeah.
this one. Right?
Yeah. The 4 from the last, you can remove it. The
Mhm.
input array ports you have to remove. Yeah.
Yeah,
Yeah. So ideally the value should be -1. Just run first.
we need to remove this one, right? Or the array of
No, you still need that the condition, right? The bottom condition.
this one,
This one, yeah.
and this condition we need to keep it as a that is the array of 0.
The max value will be your array of thing, right? Array of 0, correct?
So this one also the array of 0, right?
Right. The current max is 0 is fine. I think the
This
max value will be,
otherwise it will return something else in that case.
yeah. So the current max will be your 0. The value will
Yeah.
be 0.
Okay. Okay. It is returning -1.
Yeah.
Yes, that is correct. Yeah.
All,
Anyone -1 that is the sum of the sub-array. Yes. Understood.
all right. I'm kind of done with the interview. Like Pavel, over to you.
Shall I stop my sharing?
Yep. So basically, like what kind of I evaluated Pratik on the basis of how his fundamentals are there, his problem solving skills, like how does he come back on the defining the problem statement, then like coming up with the problem, the scope of the problem, defining the edge cases, talking about the what kind of data structure he's used in the problem, and then the complexity, right? And he talked about the different approach, uh, kind of weigh the pros and cons, and then kind of he come up with the functional code. Then he also talk about the non-functional requirement, where he talk about the concurrency and also the challenges with the large data set. So like the different approach, right? Instead of using in-memory data structure, he'll be using kind of cache. Then we also look into kind of another problem statement where we kind of finding the largest sum for the contiguous subarray given the array, and he come up with the cadence algorithm where he talk about the what is the advantage of using cadence algorithm, because it kind of solved the with respect to the time complexity and also like with respect to space complexity. So, and also he kind of went through that, the solutioning of that. And also kind of he identified the edge cases and all. So he kind of handled that as part of his kind of solution.
Guys, thank you both, Saurabh and Pratik, for this really great, exciting interview. And now I would like to ask you to provide some feedback to each other.
Saurabh is not that is acting like he's a that is leader on me, and he's a pressurizing me to solve the problem. So that's why I feel the more comfortable from the interviewer, from the Saurabh, and he is giving me the more comfortability by discussing with me about the solution and how we can solve the problem in a better way, and what could be the time complexity to solve this kind of the problem. So that is the good thing that I have learned from the Saurabh. That is, we are going from the start of the problem with the minimum requirement and with the very large data set with the actual application production code. So that is the main thing which I learned from the Saurabh. And another thing, that is, the Saurabh asked me the question with such a kind of the question which I can use the multiple data structure, and I can utilize the multiple data structure in in a efficient manner. Okay, because the problem can be solved by using the single data structure also. But Saurabh, give me a one condition, that is the we need to solve in the base time complexity. So I can think on this, and then I have given the that is solution which is giving us the better time complexity with by using the multiple data structure. So that is the learning path from me, from the Saurabh.
So, Saurabh, what will be your verdict?
I think the candidate, I mean, it's important to be candidate to be confident. Talk about the thought process with the interviewer. Ask clarifying questions, right? Because it's very important to kind of when you don't ask the clarification questions, there will be some assumptions will be made, right? I mean, the interviewer needs to know your assumptions or the expectation from the interviewer you should know, right? And also like it's very important to kind of define the edge cases, so that way it will give you kind of like perception to that interviewer that like, hey, this person is kind of not thinking into the narrow thinking. It is kind of broader thinking where he come up with the edge cases, defining the scope, and then like kind of going ahead with the solution, right? And also like I think the Pratik has kind of used the kind of right naming convention. So when it comes to kind of reading your code, right? It is kind of like where I'm like it will be easier for interview or someone to look into your code, kind of understand that what is happening within the code, right? So I think the using the right data structure, right naming convention, I think is very important. I think I mean like he came up with the kind of all the right ingredient for that interview, where he kind of asked questions, clarified, define the edge cases, come up with a solution. The code was functional. I'm like he kind of I think code was readable. Also, it was kind of following the solid principles. He came up with the data encapsulation and all, right. So ML, I think it's a kind of right ingredient in that. So I think he's kind of suitable for that role. He kind of interviewed.
If you enjoyed this video and find it helpful, don't forget to check out the links in the description to learn more about EngX and how it's transforming the way that we work. Also, make sure to subscribe to our YouTube channel and share this video with your friends and colleagues using your social media accounts, especially LinkedIn. It really helps us out. It's been Roman Zatiski here, and it's been a pleasure to have you with us. Thanks for watching, and see you next time.